So compile and execute your own tools. So one of the most attractive features of OpenFOAM is that you can basically write your own tools using the same structure of OpenFOAM to be able to solve whatever problem you are looking into. And the problem with the containers is that containers will only have the standard tools that come with OpenFOAM. So how can you have your own tool and still use the containers? So that's the purpose of this episode. So, okay, so let's go to the scripts for this episode. So you need to be 2 levels above from the scripts of the first episode. So CD 2 levels above. So you need to be at this level where all the episodes of directories are listed. So it basically is in the containers OpenFOAM workshop scripts directory. And from there, you CD to the 03 compile and execute. So we tap, we complete this and then enter. And then I only have an example for version 1912. So CD example version 1912. And there are the scripts. Well, right now I'm going to skip the step of viewing a script or exploring it, just to keep moving forward. So again, basically the idea is very similar to the previous episode. So a series of scripts that perform everything. So in this case, we are starting with the cloning of a solver that is included in the standard OpenFOAM. That solver is PimpleFOAM, and is the one that we used in the previous episode. So basically, I'm going to, well, that script copies all the source files for that solver, again, into our disk. And then also renames the solver. So now it's not known as PimpleFOAM, but it's known as my PimpleFOAM. So that's a new solver, exactly twin brother of PimpleFOAM, but with other name, and that one is yours. So we are not going to modify anything but the name, but you can keep modifying it to make it do whatever you want. But so far it is a twin brother, and we know it works. So we are not going to mess up with the solver itself. But it's going to be your own. It's not from the standard. So basically what we are going to show here is how to compile your own solver and how to use it. So the first part, the cloning of PimpleFOAM and the renaming of the files, is in the first script, and that has already been done. I'm going to work with you all the way in part B, which is the compilation of the solver. And then section C and D are basically the same as previously, extracting a tutorial and adapting the case. These scripts are indeed the same as in the previous episode. And then again, decomposing and running the solver. In this case, the solver that we are going to run is our own. So that's how this episode would flow. So part A is already done, but I'm just showing here the main command for the cloning. So in that script, we have a command that says singularity exec the image. And then if I knew, well, obviously you may know, or we could know, and indeed we know where the source files of the solvers are. So you can basically use the same syntax that we use for cloning the tutorial, but in this case I'm changing the syntax a little bit. So I'm using this --c command to catch another command to be executed inside the container. And I need to do that because I wanted to use this variable, WM project dir, and this variable is only defined inside the container. So in order to expand or evaluate this variable inside the container and not in the command line in my local host, I need to use the --c. So that's why what I'm telling is copy from whatever is the WM project dir, and then this is a bit tricky because I'm changing from single apostrophes to double apostrophes to now use variables that are defined in my local host. But anyway, all these will be interpreted as a single command by the --c inside the container. Again, this is just a trick for us to be able to use variables that are defined inside the container. But basically, it is copying some directory structure inside the container where the solvers are, under applications, solvers, incompressible, PimpleFOAM. That's where the PimpleFOAM is. And it's going to be copied into my local directory inside project dir, applications, and new solver, which the new solver is my PimpleFOAM. That has already been pre-executed, but we can check what we have after the cloning. So basically, you can ls project user dir, and you see that under the project user dir, there's only one subdirectory called applications. I'm doing this because after the compilation, other directories will appear there. So right now we only have a single directory, the applications, and below applications, see if I cd to project dir, project user dir, then tab will be applications, and if you press tab again, there is a subdirectory called my PimpleFOAM. So originally inside the container, there was sort of this kind of structure below a directory called applications. There was a directory called PimpleFOAM. This one is the copy and has been renamed to my PimpleFOAM. And inside there, we have the files, the source files for the solver. And this one, again, is the clone, is the twin brother called my PimpleFOAM. So that's the main source file of the solver. We can take a quick look into the solver. So if you do view my PimpleFOAM, you will be able to see a bit of the solver.
Alexis, when you get the chance, can you go over the bash -c trick again?
Yep. Yeah, that trick, I will explain the trick later again with some examples, maybe better examples, the trick of the --c. So this is the solver. As you can see, it includes a lot of files that are indeed not in the directory we are looking at. So all these include headers and libraries are from OpenFOAM itself. And yeah, I will not explain about the structure of the solver. So, but that is our own solver. That it's what will mimic our real life scenario. So now we need to compile it. I need to tell you about the files inside the directory make. So here is a subdirectory make. So let's go inside there and then list what is there. And there is a file named files, which I have always found a bit strange for naming something like that, but that's the file files and the file options. Inside the file options, there is a list of all the libraries that need to be linked to this solver, and all these libraries are part of OpenFOAM. So we don't do any modification on that. Inside the file files, well, this is a very short file. If we list, well, if you print the content of the file, you will see that this setting will tell the compiler, well, the compilation tool, to use this as the main source file, mypeoplefoam.c, and to put the executable in this folder. In this folder, it is referred to this variable, foam user app-bin, and the executable will have the name mypeoplefoam. So this is the setting. This setting has been modified. Originally, what it had was pimplefoam.c, and then it had foam without the user, just foam app-bin. So that's another directory. So that's the main directory where the standard tools are saved. The main directory where the user's tools are saved is referred with this variable. So that is the setting. And this is the explanation about some variables of OpenFOAM. So OpenFOAM makes use of a lot of this kind of environment variables. Most of them start with foam subindex something or WM subindex something. The setting of those variables, basically of the OpenFOAM environment, is being done by sourcing a file called the bashrc file. In our container and in an OpenFOAM installation, that bashrc file is under the directory etc, in the etc directory. So in the case of this container, we are installing OpenFOAM in OPT, OpenFOAM, OpenFOAM version 1912, and then under there we have the etc directory, and under there is the bashrc file. So for our singularity images, this bashrc file is being sourced by default every time you execute the image, or every time you use a container with that image. And that's the way we prepare the singularity images. For our Docker containers, there is no sourcing of the bashrc file. So if you, at any time you use our Docker containers, which are the first part of the building process we follow, that those Docker containers are, or Docker images are completely working. So you can use Docker for running them, but first you need to source the bashrc file. Okay, to check a clean list of the environment variables we have, let me just cd back to be consistent with the nodes. And then we already loaded the module singularity. We already defined the image we are going to use. And this is a very tricky command, which basically is using AWK to extract environment variables. Then we're using grep or egrep to extract those variables that start with foam or WM, and then we are sorting them in alphabetical order. I'm not going to explain too much about this command, and I will later come back to the bash C. But again, just to mention here, the bash C idea is execute or send this command to the container, but just as it is written here. So nothing is being evaluated, or at least nothing in between the single apostrophes regions. The container receives that command inside and then execute it. So this is, I'm going to copy paste this because this one is long. And so command C, command B. And then you have a list of the variables without their definitions. So I'm just printing the names just for you to see all the variables that are being defined. I want to check the definition of these three variables, which are WM project user dir, foam user app bin, and foam user lib bin. Those are related to our own tools as a user. So you can use printemp to display the environment, and then just catch those that have the user keyword. And I'm sorting them in reverse alphabetical order just to make the WM variable appear first. So again, I think this command should work without the bash C. But I'm used to use the bash C every time I deal with something that has to do with internal definitions in the container. I prefer to use the bash C and then send the command as it is to the container. So the main point here is that these variables, WM project user dir, is like the root, or I should not call it root, but it's the main directory from where all the user stuff is going to be saved. So right now inside the container, the WM project user dir is set to be at home of the container. Then this is the name of a user that exists for that container. So that container already has a user. It's called OF user. And then OpenFOAM, and then OF user the version. So this is basically the structure that you will have in your own computer when installing OpenFOAM. So that's the standard. You have a place for the OpenFOAM installation, and the place for your own stuff is under your own home, etc. And then if you see the place where the libraries, own user libraries are going to be kept is the same directory structure, and then a subdirectory called platforms, and then some other subdirectories. And the place where the executable of the solvers are going to be saved, which is foam user app bin, are going to be under this path defined by WM project user dir, and then platforms and some other subdirectories. So right down here is where the executable for your own tools will be, and here is where your own libraries will be. Problem is that that directory is inside the container, and you cannot write anything inside there. So the trick is to bind a local directory into this directory. So we already have the place where we put the source file for the solver, and we are going to use that same place to bind this directory, home of user OpenFOAM of user version 1912, into that place in our local host. So episode B, section B of this episode, episode 3, the script compile myPimpleFoam. The main command will be from singularity exec. Then what we are going to do is this directory that we have in the place where we have the scripts, and that is the place where we are submitting the jobs. So that directory is going to be by mounted as the home of user OpenFOAM of user version 1912. So then OpenFOAM will be looking for user's own stuff in this path, but in reality, that path is being binded to our local directory, to the place we want it to be. So then the container will read and write from there without any issues, and will compile and give you the executable in that directory structure. So then the image, and this is the compiling tool OpenFOAM uses, WMake. So let me these are the whole commands. All the time mount binding that directory. First wclean. This is inside the script. First wclean, then wmake, and then finally the last step in the script is to make a mini test, this kind of mini tests that we performed before. So it's going to be, we still need to bind mount for the container to find the executable, and then we are running the executable with the -help. So it's going to find it and give us a result. And I'm using the T command for each of these steps. So the results of wclean, or the output of wclean, will be saved in the file wclean job ID. The output of wmake will be saved in wmake job ID under the logs directory. And the output of the test, of the mini test of myPimpleFoam, will be under the logs directory myPimpleFoam.job. So let's do it. So again, we are using the containers reservation, and we need to be in the directory where the scripts are. So we need to move 2 levels above. Oh, 3 levels above. Yeah, there is where the directories are, and then submit the compilation. Dispatch -- reservation equals $my reservation. b.compileFoam. So that job is being sent to run. We can check the status of our job sq -u $user. So it's, in this case, compilation is running right now. I can type it again. Okay, I need to wait for a little bit. When this is running, you can always use tail -f slurm and the output a tail on the output file from the job, and I didn't catch it moving. It's already done, so script done. So if you did the tail -f, which is not in the tutorial itself, just press Ctrl+C to exit the tail command. So here we are. So the job is finished, and now we can list what is in the project user dir. So in the project user dir, we have now the platforms directory, and below there is where the executable is. So we can do an ls of that directory, and using ls-la project user dir platforms Linux bin, and there it is, the executable MyPimpleFoam. So you can check the output of the wmake by just printing that log file. So that log file should be in the project user dir applications, where it is where our source file is, under the logs directory, under the compile subdirectory, wmake that. So that's the output of the wmake, and there's no error in the compilation because it is an exact replica of the PimpleFoam solver, so it should be fine. You can log the result of the mini test. That's step 4, or we can jump to step 5 and execute a mini test by ourselves in the command line. So let's go to step 5 in this build section and just basically execute singularity exec let's bind. So just let me, okay. So we have here the project user dir. So that's the one we are going to bind. So again, singularity exec let's bind, but we have this directory project user dir, and bind it to what the variable wm project user dir points to inside the container, which is home of user OpenFOAM of user version 1912. So in this binding, different from the scripts, I'm not using any variable for doing the binding. In the scripts, all these paths are within variables. Here, I'm not using any variable. So I'm going to bind this, then use the image and execute my own solver, MyPimpleFoam, and whatever, in this case, help. And it's giving me a message for MyPimpleFoam. So now that's the trick. Now we have our own solver. Step 6 just is an example that if you don't bind the right path, then that solver does not exist inside the container and will not find anything. So MyPimpleFoam not found. So another way of checking that we are executing indeed our own solver. I think we should receive questions from here.
Okay, there are a number of questions and best practices that Marco has been sharing in the chat, and
Yes.
others as well. Thanks all.
So I think we can start from the last question, because Akshay was asking what to just show this kind of a risky practice. And maybe Akshay, if you want, you can just unmute yourself and ask the question directly to Alexis.
Yeah, I think what I'm trying to understand is, since the executable is located locally, is it a good practice to do this? and then kind of call it from the container itself, because the libraries are linked inside the container, if I'm not wrong, right?
Yeah, well, in my opinion, is you mean a good practice in terms of risk, isn't it? So there's no issues at all. I think it's fine, and it is very practical. So at the end, if let's say you are done with your tool and it will stay like that for a while, let's say like forever, you are not planning to change it anymore, then you can use the process you use to build your tool in a building of a container. I mean, you compile it, because indeed what we have inside the container is all the compilation of OpenFOAM itself. So there's nothing to stop you to compile your own tool there. So with Docker, you can import the source file of your tool, you can compile it inside the building process, and then you will have your tool inside the container. But the issue with that is, if you are developing your tool, then you will need to go to all this process of developing inside the building recipe of the container, which is not practical. So the way to develop your tool is to do it like this, with your own tool outside the container. Then you can do this process again and again without using any Docker file or any building process, etc. And keep developing your tool. And once you are happy and want to include it in the container as my OpenFOAM container with my super tool, then you build your container and then you use it from the inside. I don't know if that's fair enough.
Yeah, I think that answers my question. Thanks.
And then there were a few other points, Marco,
Yeah, so
if you want to.
with a similar one by Leaf and Chen, which I think you covered as well.
Yeah, so basically, yeah, I should have started with saying that we have two options. One, this one, to do everything outside the container, and the other one is put your tool inside the container. We will cover building tomorrow. I'm not planning to do the building of your own tools inside the container, but there's nothing that will stop you from doing that. So I guess, yeah, so that's the other way.
Any other questions?
No, I think we're good to continue.
Okay, so I just wanted to just to probably come back here. So again, so this is the important thing. And basically the trick is to trick the OpenFOAM installation in a way, or not to trick, but just to help to find our own source files and place where we are writing our executables using the binding. There may be some other options to do this kind of trick to at the end finish with the same result. This is just an idea that I think works fine. And one problem that we have, if you want to use some other ideas, is that, as I told you, the bashrc file is being sourced by default in the Singularity containers every time we use it. So the kind of ideas of defining variables outside the container and importing them to the container, importing the environment variables into the container, etc., do not work, because after all that import of variables, then the sourcing of the bashrc will happen. And then if you try to redefine WM project user dir from outside the container and pass it to your execution with Singularity, it will be erased and by the bash RC itself, and then you will finish all the time with this. And that is not a problem with Singularity, it's a problem with the way we built the containers in Pawsey, and that is sourcing the bash RC file every time we're using the every time you execute the images. The other option that we had was to define each of these variables one by one in the recipes and not sourcing the bash RC. That could be more practical for these kind of tricks that we are doing here, possibly, but it's more impractical for the building process because setting up each of these variables one by one and checking has been really a pain. I did that in the past, and when I found that Singularity allows you to source the bash RC file, then, well, I was more than happy to use that approach. And then seeing that at least this idea works fine too, then we are complete. So, well, it's time for breakout rooms, and basically we don't have too much time, but the idea is to execute the composition again. This is not being executed for you just to save a bit of space in the Git repo. So you need to decompose again and execute your own solver, which is, in terms of typing, it's exactly the same that we did in the previous exercise. Possibly I can just show you the main command in the running. The main command in the running, now instead of using PimpleFOAM for solving the case, is using my PimpleFOAM. And that's it. Well, and obviously using my PimpleFOAM and using the binding, then you will be able to solve your case.
Yeah, we actually had a really good question in my room. So I don't know if you want to ask it again. We also had a great explanation from Akshay. Yeah, so that might be beneficial for...
Oops.
Yeah, I could kind of just summarize the question. I think this question was like, what happens when you change some, let's say you're changing a finite volume library and you wanted some functionality that needs to be changed, which is not necessarily located in the my PimpleFOAM solver itself, but let's say some averaging utility, which is a library that is not contained in PimpleFOAM. So what if you want to change that? Do you also have to recompile the entire Docker? I think that was the question, if I understand correctly. Please correct me if I'm wrong. Maybe I understood the question differently or something. But
you mean to say user-defined library, or?
Yes, I think he wanted to check if like you'll have to recompile the Docker itself. And my understanding was like you don't really have to do that as long as you put it in the options file and you link the solver to your link the library to your solver. It should be fine the same way.
But there should be an option to do that, isn't it?
Yes.
Yeah,
and all of that exists.
Yeah, exactly. The container should be able to read that path. So in the case of Scratch, it can read everywhere. But so basically, that's the thing. So you can work as normal, really as usual, but the paths should be available for the container to be able to read and write if needed. So if the path is not an original path inside the container, then you need, with the -b option, you need to tell the container that you are going to bind this other path where your stuff is into somewhere and into a name inside the container. And yeah, so basically that's the trick. Everything should be readable.
Thanks, Akshay, for
Okay.
contributing that. Good question.
Yeah,
And
no
also
worries.
you have to read about the manual itself, OpenFOAM manual, so that you can understand better about how to do that in user-defined functions.
Yeah, exactly. All the complications for building the tools themselves and compiling your tool, etc., developing your problem. It is out of the scope of our intentions here. So that's completely OpenFOAM usage. So those problems are for you to check the manuals and check with the community how to do it. Yeah.
Okay, any other interesting questions coming out of the breakout rooms?
Here, we had a question about section A, where there was bash-c and then single quote copy.
Oh yeah, the bash
directory.
thing.
Yeah, so there's a single quote and a double quote. Alexis, can you explain that bit?
Yeah, if you see everything is together, there's no spaces. So when transiting from the single quote to the double quote, there's no space. So that is to be understood as a single string. But when you have single quotes, that part of the string is going to be keep as it is. It's not going to be changed or evaluated in the command line. While where you have the double quotes sections, if you have a variable inside there, that variable will be expanded. So if you see that double quote section had some variables that were defined by me in the lines above. So in order for them to be interpreted, I'm expanding them.
Yeah,
but there is always like a combination or many possibilities. Possibly you don't need the double quotes. Possibly with a single quote, everything will work. So you need to try. But the main thing was to use these single ones for the command to be able to catch a variable that is only visible inside the container.
So just one comment on that, because I didn't notice that bit when I was reviewing the materials yesterday. Possibly we might be able to avoid the double quotes if we define
possibly
everything with singularity and underscore variable name, as we saw in one of the webinars. So we'll post a suggestion in the Slack channel so everyone can see.
Yeah. Marco is the magician with the single and double quotes. Indeed, he's the one who taught me a little bit about that. So if he has another suggestion, just follow Marco.
Great. Thanks, Alexis and Marco.
I will show tomorrow just simple things about the bash C, or possibly put it in the notes and you can read that later.